Good afternoon all. My name is Thomas Boylston and I'm the Commercial Director of Underground. And today I'm going to be talking to you about optimising your underground drilling. I'll be talking to two specific products within our portfolio, the first being the Production Optimiser and the second will be the Development Optimiser systems. So the genesis of the Production Optimiser system was from industry clients coming to us with their problems of last hole deviation and how it was impacting the economics of their stope performance. So what causes last hole deviation? We have three main contributing factors. The first being in-hole error on the left, then alignment error on the right, and as we can see, that's going outside of the design. And then we have collar error at the bottom. And what we know is 60 to 70% of the problem happens before the hole is drilled, which is your alignment and collar error. So why does this happen? This happens because we see a stack up of error within the process. The rig, so we get mechanical slop, wear and tear, how well the operator levels that rig, markup, so the surveyor's ability to mark up that ring facing direction to get their azimuth, and then finally the operator and the ability the operator takes or the diligence to follow that process and align consistently and accurately. What we see with these inaccuracies in the drilling is a flow-on effect to the performance of the stope. As you can see in this slide here, or animation, we've got a narrow vein design stope, and we see up there, due to the inaccuracy of the drilling, over break in orange, and then we're seeing a recovery which is through under break at the top. So through these poor drilling outcomes, we see performance issues. We see over break creating dilution, under break impacting recovery, poor fragmentation creating oversize, and bridging or benching where we're impacting the productivity piece. So Hexagon has a hardware and software solution that takes a systematic approach to mitigating these areas in the process, which we've just highlighted. And through that, we start to see the consistencies of accuracy improving. So we see improvement to the alignment error and the collar error. Now that we know that they're one of the major contributing factors to the blast hole deviation, we see a downstream impact to the stope performance. And as you can see here on the bottom left, we start to see through the alignment improving, we see the stope performance improving. And in oranges, we've got the actual bulk material. And in this circumstance, we're reducing the overbreak. Now, by reducing the overbreak, we're going to reduce dilution. But what that means for the operation is our load, haul and processing costs are going to reduce. In the circumstances of underbreak, we're going to improve ore recovery. We're going to see a reduction in the refiring of oversize when we improve that fragmentation. And we're going to see better stope cycle turnovers due to the fact that we're not going to do re-drills because we're reducing our bridge tonnes. An example of this with a client at Krakow Gold Mine in Queensland, Australia. They've used the system for over 6 years now. And upon implementation, they saw a 10% point reduction in their dilutions. For them, that equated to an additional $8.2 million of ore recovered and $4.5 million less spent on the cost of dilution, which is a fantastic result for that client. Moving on to the Development Optimiser. Once again, industry clients come to us and discuss the issues of deviation in the development process. We see two main areas of variability and deviation within the development drilling process. The first is, once again, the rig. So we see mechanical slop, wear and tear within that rig, creating variability. The second, and the more predominant one, is the operator. We get different levels of age and experience of operators across the industry. And when we have the green operators and the experienced operators, that comes together to create that variable drilling, which ultimately creates suboptimal performance within the drilling process. These suboptimal parts that we see is underbrake, so we're not getting that full design volume. We see that through tightening in the shoulders and the backs and dishing at the face. This impacts the advance rate of the client, and in more extreme cases requires remedial drilling, impacting the development cycle process. The second one is overbrake, and as simple as you can see here, when we're blasting more material than required, we're increasing that load and haul cost for the client or contractor. So Hexagon, once again, takes a hardware and software solution. And what we're doing is we're creating a tool for the operator to have consistent, accurate holes. This system is designed to be flexible, so we can have that accurate boring process, and then the sensors can be taken off, so then it can be a multi-purpose jumbo and focus on ground support and scaling when required. We ran a trial at a West Australian narrow vein gold mine. The purpose of this trial was to do 18 cuts and compare how it ran against their existing process. The two metrics that we're measuring here was the advance rate and overbrake. And what we saw across those 18 cuts was a 70 mil on average increase across those 18 cuts. Now what that equated to was a value of $20,000 per rig per month. We then saw a 62% reduction in their overbrake. So their year to date went from 15.6% down to 6%. What that equated to was a $30,000 per rig saving. And when we annualised that for the operation, we saw a value add of $700,000 per rig, which is fantastic value for this new product. Thank you very much. Please come to the booth and I can discuss plenty more case studies and different value propositions that these solutions provide for our clients. Thank you.